If you click on my name below this video, it will take you to the channel page, and under About there's all the links to these books. This is a way you can help fund this channel. Cheers for now.
Now then, those of you who will have seen the isolation fault on a solar grid inverter video that I posted fairly recently will have seen that we had a problem with an underground cable, and I suspect there was a very small leakage to earth because it's been pouring with rain for weeks and weeks and weeks, and it's those cables are in a conduit, a continuous length conduit, so it shouldn't have any water in it, but the dampness has obviously got in it, and grid inverters are very susceptible to any minute leakage to earth on the DC side. That's the input side to the inverter. Anyway, so I replaced it overground with this, what I can only assume is 6mm twin and earth cable, brand new off the roll, and it was fine. Yeah, everything worked. Then the next day, with a torrential rain again overnight, the next day we had isolation fault again. So I went along the length of that cable and I had 4 big plastic water butts. So I went along and lifted the cable out of the damp grass for the majority of the length, and the isolation fault went away. Now, as a friend of mine has pointed out recently, the leakage through this cable on the high voltage DC, and we're talking 280 odd volts DC, he said the leakage through this could have just added to a bit of background leakage and just sent it over the edge, as it were, to the point where the grid inverter went, nah, I'm not having this. But I've noticed this on several other types of cable, non-solar cable, that on the high voltage DC you do get a leak to earth through this stuff, which is quite surprising. But you know, standard solar cable is multi-cord, multi-fine strand, and it's double insulated, fairly heavily double insulated. So that sort of is an interesting set of scenarios. Anyway, this is no good. I've actually sorted the problem out, but there's another grid array that really could do with an upgrade of its DC power cables. And if you use solar cable, then you've got to put it in a conduit, because solar cables, it's only about the diameter of this stuff here, which is about 6mm. You know, you get 4mm and 6mm cross-sectional area cable, but it's about 6mm in diameter or slightly less. And you got 2 of them, so you got to put them in the conduit. Or you could use armoured cable. Now, there lies the conundrum. It's all about your impact. It's all very well going off and buying 40 metres of armoured cable, but there's a cost ecologically and financially, the first being the most important. So if I've got a pile of odd bits of armoured cable and 2 lengths are sufficient to make it up, but we need to make a joint, then let's join it. I think the basic idea is that if you imagine that's one joint there, yeah, then the next joint you put slightly to one side, so you've got 2 cables, one join here, one join there, so they're not opposite each other. And then what I propose to do is to use a bit of plastic pipe, square down pipe, and cut the side off it, and use that as a mould, and then to pour pitch, hot pitch, over that joint, and let it solidify. The water's not going to get into that. So we're going to give it a go anyway. This is part of the whole thing about experimenting and let you know what I've worked out. I have actually done this before on mains, and it's worked perfectly. It's been working perfectly for over 10 years without any problem on that circuit. So let's crack on. Right, let's have a look. Sometimes you can just pull these through that outer layer. A little bit tricky filming it. There we go. And then remove the armouring. And twist it back. Now then, cutting into this is not as easy as you would think, because you don't want to damage any of the conductors, the insulation on the conductors. So it's just a matter of cutting quite gently. Yeah. And there, there's a bit of red there, so just have to be careful. Hopefully this will pull through now. There we go. I think we need to go back a bit further, or else the joint will be too long. That's a little bit better. Right, and then we want one longer than the other. So we'll have the red one longer, but it doesn't need to be as long as this, so we'll go there, and the black one wants to be down there. Right, that's a good start. I'll crack on with the other end, and then we'll see as to soldering these two together. So here's the two tails then, and I've got some bits of copper wire here, and I just want to, as you can see, I'm just wrapping those two together to hold them tight. Maybe that's a bit thin. Let's try this other stuff, which is somewhat fatter. Push it together, wrap it together, tighten it up. Hopefully you can see that. Not the easiest thing in the world to film. And just squeeze that end in. There we go. Cut that off. So we have the big soldering iron, and it's up to temperature. I'm using electrical solder because the flux is nowhere near as aggressive as plumber's solder. If you use plumber's solder and flux, then you have to wash everything off because of the acids in it. But this seems to be working quite well. Plenty of solder in there, and that wrapping holds everything together. In fact, I'd say that has worked remarkably well. There we go. Let that cool off, and then do the other one, which of course is offset, as we've said previously. And as you can see, the other one's wrapped together now. You've got to let these soldering irons heat up really well. Give them 10 minutes before you start this. It's got to be a big mass of heat to get the heat into this cable. Do you see it's melting on there now, which is perfect. And you also need plenty of solder on the tip of the soldering iron to transfer the heat. I think that'll be enough. There we go. So I've got one more to do, and then we'll sort out the pitch and the little pot that I've got for heating it up, and put a mould round this. I'm still uncertain about this. I think I might cut it off because there'll be a big blob here. Right, I'll turn you back on when I'm sort of in the right place. So it was rained overnight, but as you can see, this is a piece of the square rainwater pipe, the down pipe, and if you look here and there, those ends are inside this plastic. Anyway, I've got a piece of rod here and here which are just lifting the whole unit up, and I've just gone and dug a bit of clay
and all we want to do really is create a little dam there. I literally just went down about a foot and dug this out, and this is just a bit of a dam just to hold the pitch back when we pour it in there. You get the idea. And this here is a bit of the old external insulation. I don't quite know why I put it there, but I've put it there. Just seemed like a good idea. But the pitch will get in all amongst that. So I'm just going to mould this together and then move on with the next part of the process. So as we can see, I've put some lumps of steel and packed it all round. I mean, when this plastic gets hot, it's obviously going to bend, so we've packed it round, and this is raised up off the floor so that the pitch will get underneath, and everything seems to be about right. So now we've got to melt the pitch. So we'll just warm that up, and whilst I'm doing that, we'll break up some of the pitch. Right, I've got a face mask on. Eye protection, wellies, etc, etc. So I've turned the gas down a bit, and we'll just wait for those other lumps to soften up a bit. Shouldn't take too long. There's just got to heat this up now. We don't want it absolutely stone cold whilst we pour that pitch in. Especially the cable, just want the cable warmed up a bit. And we've got aeroplanes in the background, but I can't do anything about it now because it's time to pour the pitch. So let's just zoom out a bit. Face mask on, gloves on. We don't want any of this red hot stuff, burning stuff on my skin. And then we'll just let that cool, which will probably take quite a while. And another pour. Okay, I've removed some of the blocking there. This is cooled off significantly. Remove that spillage there. And there we are. One joint, waterproof, and it might have taken a bit of time, but it hasn't cost anything. We've used the minimum amount of materials. We've recycled some cable, not so much recycled, reused. See, if this sort of cable goes to a scrapyard, all the insulation, of course, it gets chewed up, and they don't like it because there's very comparatively weight for weight, there's not as much copper in these, so there's a lot of wasted of the insulation, etc., etc., and a lot of energy put into it, whereas we have now made our own waterproof joint, reused the cable with a minimum of energy. So perfect. So there you go, it's done. I wonder if I can just show you the end. There's the pitch, solid round there. So hopefully this has been some use, and catch up with you soon.